In this video, we'll look at measuring angles in radians, which is the preferred unit of measurement in calculus. Recall that an angle has multiple parts. It consists of an initial ray, which I've drawn here, which is then rotated some amount to a terminal ray where the angle ends. We want to measure this angle, and in order to do that, we'd like to assign a number to to represent how big this angle is, and we'll assign that value typically to some Greek letter. In this case, I'll use the Greek letter theta. So we typically use Greek letters to represent angles. In this example, the rotation that took place was counterclockwise, and our convention will be to assign a positive number to the measurement for theta. So in this case, theta will be positive. We'll say that it's a positive angle because it's counterclockwise. If in fact the initial ray was here and I rotated in the clockwise direction to get an angle theta, we would say that it's a negative angle, and we'll actually assign it a negative value when we measure it, just to indicate that rotation that occurred. So how do I go about taking this angle over here, theta, and measuring it in radians? And the answer is to take a circle of any size that you want, and you put the center of that circle at the vertex of your angle. And then you go ahead and you measure the arc length using whatever units of length you like, and we'll use inches in our example, but you might measure this arc length that's cut out by the angle. The technical term is the arc length which is subtended by the angle, and we'll call that value S. And then you go ahead and you measure the radius of your circle, so we'll measure R to be the radius of the circle that we happen to be using to take this measurement. And in order to measure theta in radians, what you do is you take theta to be equal to the arc length S. That makes sense because if I increase the size of the angle, I'll increase the size of the arc length. However, we should do a little bit more here, and in fact we're going to divide by the radius R, and that's because of the fact that you and I may have used circles of different size, and if we're going to get the same answer, we somehow have to take that into account. So the right thing to do here is to divide by the radius. So theta is S over R, and that gives you a number, and that represents the measurement of theta in radians. So let's look at an example here. I've drawn an angle. I've chosen a circle to put it around, and I'm going to take a measurement. I get out a piece of tape measure, and I measure out that arc length that is subtended by the angle, and it turns out to be 1 inch. I then get out a ruler and I measure the radius of my circle that I'm using, and it turns out to be 0.5 inches, 1/2 of an inch. So in order to measure this angle, theta, I take that arc length, which is 1 inch, and I divide by the radius, which is 0.5 inches, and when I'm done, I get 2. Notice that the units cancel each other out. Inches and inches cancel out, and I'm left with a number that in principle has no units attached to it. And that's actually quite the correct thing to write. So theta is equal to 2. However, because we may like to convey the fact that we were measuring an angle, you may prefer to write the word radians there to indicate that this was a measurement of an angle. But in principle, angles are dimensionless quantities. This means they have no units attached to them when you're doing computations. To kind of illustrate this point and why we're dividing by R in the formula here, let's suppose I took my picture here of the angle and I just blew it up and I made everything twice as big. So I've scaled everything by a factor of 2. What was 1 inch and 1/2 an inch now get doubled in length. So all my lengths that I measured before should be twice as large. The arc length will be 2 inches, the radius will be 1 inch. So when I go to measure my angle now with a bigger circle, I get 2 inches over 1 inches, the units cancel out, and I get 2 over 1. I get the same value. And that makes sense. The size of the angle itself in either picture is the same. The lengths have doubled, but the angle has not doubled. And this is what we mean when we say an angle is dimensionless. Angles don't scale with changes in lengths. Let's look at a couple of examples of some reasonable angles here. So I'm going to take theta to be 1 revolution. That means 360 degrees in our commonly used unit of measurement for measuring an angle. And so I'm going to take that initial ray and I'm going to rotate it all around, and I line back up. My terminal ray is on top of it again. So you only really see 1 ray. If I want to measure this in radians, what I need to do is take the circumference of that circle that I've drawn here, and I need to divide by the radius of that circle, and I should get the measurement in radians. So I look up the formula for the circumference of a circle. It's 2 pi times whatever the radius happens to be that I'm using, and I divide by that radius. Those will cancel out, and I'll get 2 pi. Again, I'm writing radians here to indicate that this angle of 1 revolution, or 360 degrees, is equivalent to 2 pi when measured using this system of units. However, there's technically no units attached to this. So 360 degrees is 2 pi radians. If I take half of that, I get 180 degrees, so that's pi radians. That's kind of a good anchor to remember, a good conversion factor to remember this connection here, that pi radians corresponds to 180 degrees, so that's pi. If I cut that in half again, I get a 90-degree angle, so 90 degrees must be half of that, pi over 2. And if I cut that in half, I'll get a 45-degree angle, which must be pi over 4. Again, in radians, notice I'm not writing any units over here when I talk about the radian measure of the angle, but I must do it here to indicate degrees. Okay, finally, let's look at a quick example here. Why don't we sketch the angle minus 3 pi over 4? So what I'm going to do is try to just visualize what that angle represents. Notice it's going to be minus 3 times pi over 4, and we just discussed pi over 4 corresponds to 45 degrees. So here's what I like to think about. I like to think about it as a negative angle, and it's going to be 3 copies of 45 degrees. So here's 180 degrees. I'm going to cut that in half. That cuts everything into 90-degree pieces, and then I'm going to cut all of those in half, and so each one of these little pie slices here is going to be 45 degrees. And what I need to do is start counting in the clockwise direction because it's a negative angle. That's 45. That's another 45 degrees. That's 90 degrees. And so 3 45 degrees, 3 of these 45 degrees in that clockwise orientation gives me this angle here. And that angle is, in fact, my minus 3 pi over 4.